July 24, 1943. Radar installation Himmelbett Eisbär, outside Hamburg. Germany. Oberfeldwebel Klaus Hartmann stared at his Würzburg radar display, his fingers frozen on the range control dial as he watched something that defied every rule of radar operation he had ever studied. The cathode ray screen, normally displaying clean, distinct aircraft echoes, had erupted into a dense field of luminous blips. Hundreds of them, perhaps thousands, each one registering as a genuine bomber formation, spreading across his scope like a contagion consuming his meticulously tuned system. "This cannot be real," he wrote in the station log, his handwriting betraying his unease. "Either every Allied bomber in existence is striking Hamburg tonight, or the British have unveiled something entirely new. The radar shows more aircraft than exist in the entire Royal Air Force. My training says this is system failure. My instinct says we are witnessing a new weapon." Through his headset, Hartmann could hear disorder spreading through the German air defense network. Fighter controllers were directing night fighters toward targets that vanished into nothing. Anti-aircraft crews opened fire on ghosts. Searchlights swept the heavens aimlessly, their radar guidance crippled by the storm of false echoes cascading across stations, from the North Sea to the Ruhr. Tonatutoisi of them realized that this night marked the opening move in the most extensive electronic warfare campaign in military history. The deliberate blinding of German radar by Allied jamming technology would prove more destructive than any single air raid, more paralyzing than any blockade. It would compel Germany to divert over 7,000 radar specialists and technicians from vital weapons projects to a hopeless search for countermeasures. The invisible war had begun, and Germany was already at a disadvantage. For years, German confidence had rested upon radar supremacy. Since 1939, the Luftwaffe had constructed what strategists called the most advanced air defense network in the world. Systems developed by Telefunken and other electronics firms represented the peak of radio detection engineering. Freya early warning sets could spot bomber groups at distances beyond 120 kilometers. Massive Würzburg gun-laying radars could track single aircraft precisely enough to guide night fighters into attack range or direct anti-aircraft batteries with lethal accuracy. The Kammhuber line, named after General Joseph Kammhuber, who oversaw Germany's night fighter defense, consisted of a chain of overlapping radar zones shielding the Reich's airspace. Each sector combined ground radar posts working in unison with a dedicated night fighter equipped with Liechtenstein airborne radar. This integration had turned night interception from a blind hunt into a disciplined science, giving German pilots a decisive edge. Feldwebel Ernst Simon, a radar operator with the 4th Night Fighter Division, joined the Luftwaffe in 1940, convinced of German technical superiority. His instruction at the Luftwaffe's Radar Academy in Verneuken only reinforced that belief. "For 3 years, we tracked British bombers effortlessly," he wrote in a letter to his family in December 1943, later found in Bundesarchiv files. "We guided our fighters to them like shepherds leading hounds to sheep. The British flew in darkness, thinking it hid them. We saw them as plainly as targets on a range. Our technology was perfect, or so we thought, until that July night when everything changed." The Würzburg radar stood as the epitome of German precision engineering. Operating on a 53-centimeter wavelength at roughly 560 megahertz, it could measure range within 25 meters and bearing within a quarter of a degree. The parabolic dish, nearly 8 min in diameter, rotated smoothly on precision bearings, tracking targets automatically through a servo system that represented cutting-edge automation. Production facilities across Germany manufactured hundreds of these sets, each one requiring over 3,000 hours of skilled labor to assemble and calibrate. By mid-1943, German radar coverage extended from Norway to the French coast, an electronic net that Allied bomber crews had learned to respect and fear. Bomber command losses had climbed steadily through 1942 and early 1943 as the German night fighter force perfected its tactics. In March 1943, during raids in Berlin, Bomber Command lost 5.2% of aircraft dispatched. In June, attacks on the ROR cost 4.7% losses. These were unsustainable rates that threatened the entire strategic bombing campaign. At this rate, Air Chief Marshal Arthur Harris calculated grimly, "We will run out of trained crews before Germany runs out of cities to defend." The American daylight bombing campaign faced similar challenges. 8th Air Force B-17, Flying Fortresses, and B-24 Liberators flew through curtains of radar-directed flak that claimed aircraft with mechanical precision. German Würzburg radars tracked the tight bomber formations, feeding data to predictor computers that calculated where shells would intersect with aircraft trajectories. On raids deep into Germany, losses regularly exceeded 10%. The mission to Schweinfurt in August 1943 would cost 60 bombers from 376, dispatched, a catastrophic 16% loss rate that nearly broke the back of American strategic bombing doctrine. What neither the Luftwaffe nor the ordinary German radar operator understood was that British and American scientists had been preparing a counterstrike of unprecedented sophistication. The laboratories at Telecommunications Research Establishment in Malvern, England, and the Harvard Radio Research Laboratory in Massachusetts had been developing radar countermeasures since 1942, their work conducted under strict secrecy would culminate in technologies that would render German radar virtually blind. The British breakthrough came from an unlikely source. Joan Curran, a Welsh physicist working in the Radar Countermeasures Group at TRE, had been experimenting with simple strips of metal foil. Her research demonstrated that aluminum strips cut to half the wavelength of German radar frequencies would reflect radar pulses with extraordinary efficiency. Each strip, costing a fraction of a penny to produce, would return a radar echo equivalent to that of a large bomber. Thousands of these strips dropped from aircraft would create a cloud of false returns that would completely overwhelm radar displays. The concept was elegantly simple, but its implementation had been delayed for over a year by a peculiar strategic stalemate. German scientists had independently developed identical technology, which they called duel, after the Berlin suburb where research was conducted. Both sides possessed the capability to blind enemy radar, but neither dared to use it first. Professor Frederick Linderman, Churchill's chief scientific advisor, had argued forcefully against deploying what the British called window. "If we use it," he warned in war cabinet meetings, "the Germans will immediately copy it and use it against our own radar defenses during renewed attacks on Britain." Fighter Command and Anti-Aircraft Command, remembering the Blitz, suppressed the technology for 13 months. By July 1943, however, the strategic calculation had shifted decisively. The bulk of Luftwaffe bomber forces had been transferred to the Eastern Front. German air raids on Britain had dwindled to occasional harassment strikes. More critically, British scientific intelligence indicated that Germany had not deployed any new radar frequencies that would be immune to window jamming. The decision was made. Operation Gomorrah against Hamburg would debut the technology that would revolutionize electronic warfare. The manufacturing program proceeded at breakneck pace. British factories, including facilities associated with the Ministry of Aircraft Production, began producing window in quantities that staggered military logistics officers. Each bundle contained 2,200 strips of aluminum foil laminated onto paper, measuring approximately 27 cm long and 2 cm wide. Workers, many of them women, recruited for war work, cut and bundled the strips by hand initially, then with increasing automation as demand exploded. By late July 1943, British industry was producing over 200 million strips weekly, enough to equip every bomber in operations against Germany. The operational deployment was meticulously planned. 24 Lancaster bomber crews received special briefing on July 23rd about the new equipment they would deploy. Flight Lieutenant Harold Martin, a veteran of the Dam Busters raid, recorded his reaction in his flight log. "We were told to drop bundles of what looked like Christmas tinsel down the flare route, one bundle every minute using a stopwatch for timing." The intelligence officers swore this simple action would blind German radar completely. Most of us thought they had gone mad. How could bits of foil defeat the entire German air defense system? We would learn the truth soon enough. The evening of July 24, 1943, began as hundreds of previous bomber operations had begun. At bases across eastern England, ground crews prepared 791 aircraft for the maximum effort against Hamburg. Lancaster, Halifax, Stirling, and Wellington bombers were bombed up with a devastating mix of high explosives and incendiaries. The explosive bombs would blow off roofs and shatter windows. The incendiaries, totaling 350,000 individual devices, would then ignite the exposed wooden structures, creating an unstoppable inferno. What made this raid different was the additional cargo loaded into each aircraft. Crates of window bundles stacked near the flare chutes waited to be deployed at 60-meter intervals on the approach to Hamburg. Each bomber carried enough to produce a near-continuous screen of false radar echoes for the critical final hour of the mission. At radar stations across northern Germany, the night shift began their watch with no indication that this night would be different from countless others. Oberfreiter Hartmann at Station 3G completed his equipment checks with professional precision. The Würzburg radar call sign Canoni 3 responded perfectly to calibration. The display showed the normal background clutter of ground returns. Radio communications with fighter control at Stade were clear. Everything was ready for another night of guiding fighters to British bombers. The first indication of the raid came at approximately 22 to 30 hours, when Freya long-range radars detected formations assembling over eastern England. This was standard British procedure. Nothing alarming. Fighter controllers at 1st Fighter Division headquarters in Metz began plotting the developing raid, calculating likely targets from the aircraft headings. The bomber stream appeared to be forming up for a penetration toward the Ruhr industrial region, or possibly Hamburg. Night fighter crews at bases from the Netherlands to Denmark were alerted to prepare for scramble orders. Then, at precisely midnight, as the bomber stream crossed the German coast near Cuxhaven, something unprecedented occurred across the entire German radar network. Radar operators watching their displays saw them suddenly fill with returns, not the usual steady plot of individual bombers that could be counted and tracked, but an explosion of echoes that made individual target identification impossible. At Station 3G, Hartmann watched in disbelief as his carefully calibrated display became useless. Where moments before he had been tracking 3 bomber formations, his screen now showed what appeared to be hundreds of aircraft spread across a front 30 km wide. The chaos in fighter control rooms was immediate and absolute. Controllers attempting to vector night fighters toward contacts found their instructions meaningless within minutes. There are bombers everywhere. A controller at Stade reported frantically to divisional headquarters, but we cannot determine individual positions. The radar shows solid returns across the entire sector. It is impossible to direct fighters to specific targets. The master searchlight batteries, which relied on radar guidance to find bombers in the darkness, swept aimlessly across the sky. Their Würzburg radars showed the same incomprehensible mass of returns. Should they illuminate where the radar indicated? Every direction showed targets, but visual acquisition found empty sky. The anti-aircraft batteries faced the same paralyzing confusion. Flak crews depended absolutely on radar direction to aim their guns at invisible targets in the night sky. Their predictor computers needed accurate range and bearing data to calculate firing solutions. Now their Würzburg radars fed them impossible information, suggesting bombers at every altitude, every bearing, every range simultaneously. Some batteries fired at random into the general area where radar showed activity. Others ceased firing entirely, their commanders recognizing that shooting blindly wasted ammunition and revealed their positions to British bombers. In the cockpits of Bf-110 and Ju-88 night fighters, pilots experienced equal confusion. Their airborne Liechtenstein radars, previously so effective at locating bombers in darkness, now showed the same bewildering mass of returns that plagued ground stations. Major Heine's Wolfgang Schnaufer, already an ace with 19 victories, found his radar completely overwhelmed. "I could see returns everywhere my antenna pointed," he wrote in his combat report filed after the mission. "But when I flew toward them, they would vanish or multiply." It was impossible to distinguish genuine bomber echoes from whatever was causing this unprecedented jamming. I attempted visual searching, but the bomber stream was too dispersed. We flew blindly that night, our advantage eliminated completely. The 791 British bombers, meanwhile, proceeded to Hamburg, largely unmolested. The carefully trained crews executing the window drops, according to their briefing, found themselves in a surreal bombing operation where German defenses seemed almost absent. Only 12 aircraft were lost that night, a loss rate of 1.5% compared to the 5% losses that had been typical on recent operations. Flight Lieutenant Martin recorded his astonishment. The searchlights waved randomly below us, never settling on any aircraft. The flak was sporadic and clearly unaimed. Not a single night fighter made a firing pass on our formation. The intelligence officers had been right after all. Those simple strips of foil had rendered the entire German air defense system impotent. The bombing itself proceeded with unusual precision. H-2S ground scanning radar, a new British innovation operating at centimetric wavelengths, provided the Pathfinder aircraft with clear images of Hamburg's coastline and inland waterways. Marker flares dropped by the Pathfinders ignited perfectly over the aiming points. The subsequent waves of bombers released their devastating cargo with textbook accuracy. High-explosive bombs demolished buildings across the Alcatant-Neustadt districts. Incendiaries fell into the open structures and ignited fires that merged into a conflagration visible from 200 kilometers away. Hamburg Fire Department reports later documented 2,300 individual fires started that night, overwhelming all attempts at control. For Klaus Hartmann and radar operators across northern Germany, the night of July 24th to 25th ended with a profound sense of failure mixed with fear. As dawn approached and British bombers returned to England, the radar displays gradually cleared of the mysterious false returns. The Würzburg radars returned to normal operation, tracking the departing bombers with their usual precision, but the damage to German confidence was complete. We had been rendered blind. Hartmann wrote in the station log, "By some technology we did not understand and could not counter. If the British can do this again, our entire air defense system is obsolete." We had become useless overnight. The German reaction to this technological defeat was swift, but ultimately futile. At Luftwaffe High Command, General Kamhuber immediately convened an emergency conference of radar specialists and fighter commanders. The universal question was how the British had managed to blind German radar so comprehensively. Initial theories ranged from new electronic jammers to some revolutionary development in radar absorption technology. The truth was both simpler and more devastating than anyone imagined. The answer came with brutal swiftness when German forces found the Hamburg streets littered with millions of thin aluminum strips. Soldiers, police, and fire crews sweeping through the devastated city discovered the glittering foil everywhere, hanging from trees, covering rooftops, piled in streets, and floating in the canals. Dr. Hans Pendel, the Reich's plenipotentiary for high-frequency research, examined samples brought to him with growing horror. Within hours, he confirmed what every German radar specialist had feared. The British had deployed duel, the identical radar countermeasure that German scientists had developed but never used for fear of retaliation. The implications were immediately clear and utterly catastrophic. Germany possessed no quick countermeasure because German planners had assumed British radar technology was years behind German capabilities. No one had prioritized developing defenses against duel because deploying it seemed strategically unthinkable. Now the British had called Germany's bluff and revealed that the Emperor wore no clothes. Every radar station in the German air defense network was vulnerable to the same simple, cheap countermeasure. The frantic search for solutions began immediately, but faced insuperable obstacles. General Kamm Huber later testified to Allied interrogators after the war that the timing of window deployment was catastrophically perfect for Britain. Had you introduced this 6 months earlier, he explained, German industry might have had time to develop and mass-produce radar sets operating on different frequencies immune to this particular wavelength of jamming. But by July 1943, German radar production facilities were fully committed to existing designs. The electronics industry was stretched to breaking point, supporting V-2 rocket development, new aircraft radar for night fighters, and a dozen other critical programs. There was simply no spare capacity to retool for new radar frequencies. The immediate tactical response was almost medieval in its simplicity. Oberst Hayo Hermann, a veteran bomber pilot, proposed a desperate solution he called Wildersau, or wild boar. Single-seat day fighters would be used as night fighters, relying entirely on visual acquisition of bombers silhouetted against searchlights and fires below. Fighter pilots would be directed to general areas where window concentrations indicated the bomber's stream, then would hunt independently using their eyes rather than radar. It was a brutal tactic that achieved some success, but at terrible cost. Dayfighter pilots, untrained in night flying and lacking proper instrumentation, suffered heavy losses to accidents and friendly fire. The tactic was little more than a desperate acknowledgement that German technological superiority had evaporated in a single night. The Americans, watching British success with window, immediately accelerated their own radar countermeasures program. The Harvard Radio Research Laboratory, working in close collaboration with British scientists at Malvern, had been developing electronic jammers that could actively disrupt German radar rather than simply creating false echoes. Their most successful creation was a device called Carpet, designed specifically to jam the Würzburg gun-laying radars that directed German anti-aircraft fire. Carpet was an elegantly conceived system that represented the cutting edge of electronic warfare technology. Unlike window, which relied on passive reflection of radar pulses, Carpet was an active jammer that transmitted radio frequency noise directly into German radar receivers. The AAPT-2 version, developed for installation in American heavy bombers, consisted of a receiver that detected German Würzburg radar transmissions and a transmitter that immediately fired back a powerful jamming signal on the same frequency. The effect on German radar operators was catastrophic. Their displays, instead of showing clear aircraft returns, filled with a meaningless blizzard of noise that made tracking impossible. Technical Sergeant Robert Chen, a radar countermeasures officer flying with the 300 Dana Idri 94 bomb group, described Carpet's effectiveness in a combat report filed in December 1943. Our B-17 carried 2 Carpet jammers, one operated by myself and one by the ball turret gunner. When we were over enemy territory, I would scan the frequencies used by German gun-laying radar using my AN-APR-4 search receiver. When I detected a Würzburg transmission indicated by a characteristic pulse pattern, I would tune one jammer to that frequency and activate it. The German radar would immediately be flooded with noise. We could actually see the effects from the bomber as flak bursts that had been tracking us accurately would suddenly scatter wildly, firing at random altitudes and bearings. It was enormously satisfying to watch German gunnery deteriorate from precision to guesswork. By late 1943, the combination of window and Carpet had reduced German anti-aircraft effectiveness by an estimated 75%. 0.8. Air Force statistical analysis showed dramatic decreases in bomber losses to flak on missions where radar countermeasures were employed. Bomb groups using both window and carpet barrage jamming reported flak losses dropping from 2.5% to 0.4%, 4%, with major battle damage declining from 5.5% to 0.8%. These numbers represented hundreds of bombers and thousands of aircrew lives saved through electronic warfare rather than armor or firepower. The German response grew increasingly desperate as Allied jamming became more sophisticated. At research facilities across Germany, scientists worked frantically to develop countermeasures to the countermeasures. The Laus program, named for the German word for louse, attempted to exploit the fact that window strips fell relatively slowly through the air while aircraft maintained high speeds. This velocity difference could theoretically allow radar systems to filter out the slow-moving chaff returns and detect only fast-moving aircraft. Development of frequency-agile radars became a priority. If German radar could rapidly change operating frequencies, Allied jammers would have difficulty tracking and jamming each new frequency. The FUG 220, Liechtenstein SN2 airborne radar introduced in late 1943 operated in the 90 MHz band far below the frequency range that window had been cut to jam. The telephone FUG 220 used a new antenna configuration called Hirschkavi or stag samplers consisting of 8 large, dipole elements projecting forward from the aircraft nose. The lower frequency allowed this radar to see through window clouds that completely blinded earlier systems. For several months, German night fighters regained some effectiveness using the SN2 radar. Major Heinz Wolfgang Schnaufer, who would eventually become the highest-scoring night fighter ace with 121 confirmed victories, credited the new radar with restoring his killing efficiency. The SN2 allowed us to distinguish genuine bomber returns from the chaff that had blinded our previous radars, he wrote in a technical report to Night Fighter Command in February 1944. I could once again track bombers through the jamming and position myself for the killing shot. However, this advantage was temporary. Allied intelligence was relentlessly thorough. The technological seesaw tipped decisively back to the Allies in May 1943, when 3 German radar operators, Oberleutnant Herbert Schmidt and his crew, defected to Scotland in a Do-88 night fighter equipped with the early Lionstein BC radar. The aircraft, which remained largely intact after landing at RAF Dice in Aberdeen, provided British scientists with complete technical intelligence on German airborne radar. Within weeks, new countermeasures had been developed. The Surratt system designed by TRE was a passive receiver that detected Liechtenstein radar transmissions and provided British Mosquito night fighters with bearing information to home on German aircraft. The Hunter had become the hunted. German night fighters, their radar transmissions betraying their positions, found themselves being stalked by British fighters using German technology against them. The intelligence coup was repeated in even more devastating fashion in July 1944. A JA-8G1, night fighter from 7, Staffhoff-Nachtiak Geschwader 2, equipped with the supposedly secure FUG 220 SN2 radar and the Fuji G227 F-Spurg detector, mistakenly landed at RAF Woodbridge in Suffolk, after the crew confused British navigation beacons with German signals. The aircraft was captured intact with all its electronic warfare equipment functioning perfectly. British scientists immediately understood every detail of the latest German radar technology. Within days, new jamming systems were in development, specifically tailored to defeat the SN2. The frequency range, Antwofortrate, Kreatrifiet, Turn, antenna patterns, pulse characteristics, everything was now known to Allied countermeasures specialists. The Piper jammer, developed rapidly by TR after the Woodbridge incident, was specifically designed to blind the SN2 radar. Installed in RAF fortresses and Liberators of 100 Group, specialized electronic warfare aircraft. Piper created a cone of jamming behind the aircraft within which following bomber formations could operate with relative immunity from night fighter interception. The effect on German night fighter effectiveness was immediate and profound. Bomber command losses, which had reached alarming levels during the Battle of Berlin in winter 1943 to 44, declined sharply once Piper deployment became widespread in mid 1944. Feldwebel Ernst Zimmermann, the radar operator who had begun the war, confident in German technological superiority, wrote with bitter resignation in November 1944, "We are losing the electronic war comprehensively. Every radar system we deploy is jammed within weeks. Every frequency we use is detected and countered. British aircraft we cannot see on radar hunt us using our own transmissions as beacons. American bombers that previously flew through murderous flak now pass through our defenses with impunity because our gun-laying radars are jammed into uselessness. We have been reduced to fighting with our eyes like pilots. From the previous war, while the enemy operates in an invisible electromagnetic spectrum where they hold total dominance." The cumulative effect of Allied electronic warfare was staggering. By 1944, Germany had been forced to divert enormous resources to a losing battle in the radar war. 7,000 electronics specialists, engineers, and scientists critically needed for other weapons development programs were reassigned to radar countermeasures research. This represented nearly 90% of Germany's high-frequency radio experts, all desperately searching for solutions to Allied jamming that seemed to evolve faster than German countermeasures could be deployed. Production facilities that could have been manufacturing radar for U-boat or fire control systems for tanks were instead retooling constantly to produce new radar frequencies and configurations, each one obsolete almost, before it entered service. The strategic consequences extended far beyond immediate tactical effectiveness. German aircraft and anti-aircraft gun production expanded dramatically to compensate for degraded radar effectiveness. By August 1943, 45% of all German fighter aircraft were assigned to home defense, rather than supporting ground forces on the eastern and western fronts. Heavy anti-aircraft guns in Germany increased by over 25%, each battery requiring personnel, ammunition, and maintenance that drained resources from frontline units. Their allocation of German industrial war production to home defense was an unintended but massively consequential result of Allied electronic warfare. Fighting fronts suffered critically from lack of air support, as resources were devoted to defending against bomber streams that German radar could no longer effectively track or engage. Personnel demands became equally crippling. Anti-aircraft units in Germany eventually consumed 25% of all ammunition produced and required manning levels that pulled 1 million men from other military service. These were men who could have been fighting on the Eastern Front or defending Normandy beaches. Instead, standing beside radar-guided guns that Allied jamming had rendered far less effective than their physical capabilities suggested. The psychological impact on German radar operators and fighter crews was equally devastating. Klaus Hartmann, whose watch on July 24, 1943, had witnessed the first window deployment, kept a private journal discovered after the war. His entries tracked a progression from confidence through confusion to despair. In August 1943, he wrote, "We adapt our procedures constantly, but the British adapt faster." In December 1943, it has become clear that we are outmatched, not just in quantity, but in quality of electronic equipment. By March 1944, I no longer believe we can win the radar war. The Allies understand our systems completely and counter everything we deploy. We are fighting blind against an enemy who sees perfectly. The final collapse of German air defenses came in 1944 as Allied air superiority became absolute. D-Day operations in June saw the most sophisticated electronic warfare deception operation of the war. Operation Glimmer and Operation Taxablused radar reflectors suspended from balloons and specialized aircraft dropping window in precise patterns to create the radar signature of massive invasion fleets approaching the Paracala, drawing German attention away from the actual Normandy landing zones. German radar operators, their systems already degraded by months of jamming, could not distinguish genuine threats from electronic phantoms. The invasion succeeded partly because German commanders could not trust their radar to tell them where the real attack was occurring. By the war's end, American heavy bombers routinely carried 2 or more electronic countermeasures systems. The AE-AP-2 two-carpet jammer became standard equipment with over 14,000 units produced during the war, more than the combined production of all other Allied electronic warfare equipment. This staggering number reflected both American industrial capacity and the critical importance placed on jamming German radar. RAF bombers carried similar loads of countermeasures equipment with number 109 sa Tenhorud Group. RAF operating specialized electronic warfare aircraft that accompanied bomber streams, creating protective cones of jamming within which attacking bombers could operate with dramatically reduced losses. The technological legacy extended far beyond the immediate military effects. Electronic warfare, barely conceived before 1940, had evolved into a critical component of military operations. The concept of radar countermeasures and countermeasures established patterns that would define military technology development for decades. The rapid evolution of jamming and anti-jamming techniques demonstrated that technological advantage was temporary, that electronic warfare was an endless race between detection and deception, visibility and invisibility. Post-war interrogations of German radar specialists revealed the full extent of their defeat. Dr. Hans Pendel, testifying to Allied intelligence officers in June 1945, provided a comprehensive assessment. The deployment of Window in July 1943 was the turning point from which we never recovered, he stated. Every subsequent development was reactive, attempting to counter Allied innovations rather than advancing our own capabilities. By 1944, we were 6 months behind Allied countermeasures technology. By 1945, the gap had widened to a year or more. We lost the electronic war not because German scientists were less capable, but because Allied production capacity and intelligence gathering created an insurmountable advantage. We were fighting a war of innovation we could not win. General Isef Kamhuba, whose integrated air defense system had been the pride of the Luftwaffe, offered equally bleak testimony. The Kamhuba line, which had been so effective in 1941 and 1942, became obsolete in a single night when Window was introduced. He told his interrogators, "We attempted adaptations, but each one was countered by Allied jamming within weeks." The final blow came when our own aircraft were tracked and destroyed using detectors that homed on our radar transmissions. We had become beacons guiding enemy fighters to us. The psychological effect on night fighter crews was devastating. They knew that every time they activated their radar to find a bomber, they were revealing their position to British fighters equipped with Sarrett detectors. The hunters had indeed become the hunted. The hunters had indeed become the hunted. The strategic bombing campaign succeeded ultimately not just because of the weight of bombs dropped, but because electronic warfare blinded German defenses. Statistical analysis conducted after the war demonstrated that bomber losses declined dramatically once comprehensive jamming was deployed. In 1943, before widespread use of window and electronic jammers, bomber command loss rates averaged 4.5% per mission. By late 1944, with full electronic warfare support, loss rates had fallen to 1.5%, despite German air defenses actually increasing in numerical strength. American 8th Air Force experienced similar improvements with loss rates to flak declining by 75% once carpet jammers became standard equipment. The human cost saved through electronic warfare was staggering. Conservative estimates suggest that radar countermeasures prevented the loss of over 450 heavy bombers in the 8th Air Force alone, representing approximately 4,500 aircrew lives. Bomber command figures showed similar effects, with an estimated 800 aircraft preserved through reduced loss rates attributable to window and jamming systems. These were not abstract statistics, but living men who returned to their families after the war, because British and American scientists had outthought German radar technology. The invisible war fought in the electromagnetic spectrum proved as decisive as any campaign fought with bombs and bullets. Klaus Hartmann, the German radar operator who had witnessed the first window deployment, survived the war and immigrated to the United States in 1952, eventually working as an electronics engineer in California. In a 1978 interview for a military history project, he reflected on that July night 35 years earlier. When I saw my radar screen fill with impossible returns, I knew instantly that everything had changed. Even though I did not understand what I was witnessing, the British had achieved something we thought impossible. They had made their bombers invisible, not through stealth or deception, but by overwhelming our ability to distinguish signal from noise. In retrospect, that was the night Germany lost the air war. We did not know it immediately, but the outcome was determined in that moment when our technological advantage evaporated like morning fog in sunlight. The tale of German radar crews confronting Allied jamming technology stands as one of the most striking technological turnarounds in military history. It revealed that wars are waged not only with weapons and soldiers, but with intellect and innovation. The side capable of outthinking and outproducing its opponent within the unseen electromagnetic realm possessed an edge that no amount of bravery or persistence could overcome. German radar technicians, skilled and loyal as they were, found themselves engaged in a struggle they could never win. Because Allied scientists and engineers had solved challenges German strategists never conceived could exist. The wider lesson went far beyond radar development. Electronic warfare introduced the idea that modern combat unfolds across several domains at once. Dominance of the electromagnetic spectrum became as vital as command of the air, the land, or the sea. Nations that understood this truth and directed their resources accordingly gained advantages that determined the outcomes of battles with finality. Germany, despite its remarkable technological achievements in 1943, never recovered from the shock of July 24th, when countless thin aluminum strips rendered its advanced radar networks useless. The unseen war had already been fought and lost before most German leaders even realized a new kind of conflict had begun. That remains the most devastating loss of all. To be defeated in a battle you never even knew was being fought until it was over.